Hello and good evening, CSI258 Section 847 students for the second 8-week term of the spring 2015 semester at Anne Arundel Community College. This evening's Packet Tracer tutorial is a fantastic activity, very real world, and it's Packet Tracer 7.3.2.8, where we're going to be configuring generic routing encapsulation tunnels over IPSec. And if you remember from the previous activities we've done, when we did just the IPSec configuration, IPSec will support unicast traffic and only unicast traffic. So if you wanted to run a dynamic routing protocol like EIGRP or OSPF on top of IPSec, you wouldn't be able to do that. So one of the methods to make that happen is to use the generic routing encapsulation or GRE tunnels between the sites. And remember to think of a GRE tunnel as simply your dedicated point-to-point circuit, right? So we're going to configure it very similarly to simply a dedicated point-to-point circuit that would run between two serial links. However, in the case of a GRE tunnel, we're going to go ahead and simulate the serial links by creating tunnel interfaces. And so as you can see here in our activity, we've got two GRE over IPSec tunnels that we're going to create. And the reason that you say GRE over IPSec is that we configure the IPSec profiles on the interfaces. We configure our crypto maps and we apply them to the interfaces with the transform sets. We take care of our IKE phase 1 and phase 2, and then we overlay the GRE tunnel, right? So the GRE tunnel becomes an overlay on top of the already established IPSec. So you'll hear people commonly refer to it as, oh, it's a GRE IPSec tunnel. So GRE over IPSec. And when we do that, we create those virtual serial point-to-point interfaces, right? The dedicated circuit interfaces, and we do it in the form of a tunnel interface. So again, they're not serial interfaces. I'm just comparing them to what you would get, and a great way to remember what is a GRE point-to-point tunnel. So we're going to go ahead and get this site-to-site IPSec VPN configured here. And so let's start in. They want us to check connectivity. So I'm going to hop onto router 1 here. And let's bring router 1 down. And I'll get them all pulled up. That's router 2 there. And you can see they don't have them labeled for us, but that's okay. We'll make do. And router 3. Alright, so from router 1, the activity is asking us to initially ping the IP address of the serial 000 interface on R2. So I'm going to say ping, and it is 64.100.13.2. Alright, so from router 1, I can easily ping router 2, no issues. So let me try to ping the IP address of router 3, which is 64. Excuse me. 102.46.2, and again, I've got connectivity. So from a connectivity perspective, I can ping both R2 and R3 from R1. But let's see what happens. Can I ping from R3 over to R2? So 64.100.13.2, I can. So I've got connectivity all the way through the cloud, and this cloud right here is going to be sort of simulating our unsecured network, and we'll go ahead and call that the internet. So we've got, and I think I'll move this up just a little bit here so we can see those IP addresses. There we go. So we've got what we'll call site 1 here, right, or site 1 up here, site 2, router 2, and then site 3. And this could be New York, and so we'll go ahead and draw up a little scenario here. So we can say that this could be New York, this could be San Francisco, and this could be Los Angeles. And this is router 3, and this is router 2, and this is router 1. And so there is no IPSec tunnel here, right? Or no IPSec, no GRE over IPSec between 2 and 3. So let's keep that in mind. Our tunnels, right, or our IPSec, excuse me, our GRE over IPSec are going to be between 1 and 2 and 1 and 3, right? There is no tunnel going back and forth here between 2 and 3. So keep that in mind. And let's go ahead and get our configuration set up. So you can almost think of this as like a hub and spoke, where our hub is going to be New York, and we're setting communication up with our spokes. So we've confirmed our connectivity. Let's attempt to ping the IP of server 1, which is up here, from laptop L2. So let's go ahead and give another assist here. So this is laptop 2, this is PC 3, and this is server 1. So what we're going to try to do now is ping from laptop 2. We'll bring this down here. And it wants us to attempt to ping actually from server 1. So let's get server 1 up as well. So we'll run the command prompt here, and I'm going to say ping, and it wants us to try to ping. Oh no, it is from, I'm sorry. So from L2, oh, from server 1, the address of 1 from L2. So there we go, sorry about that. So let's go ahead and say ping 10.0.0.2. So can I ping from laptop 2 to server 1? And I can't, right? I can ping from router 1 to router 2, but why would you think I can't ping? Why is that? Well, if you're thinking that my source address is 172.16.0.2, you're correct, that's the laptop 2 IP, and my destination address is 10.0.0.2. So what's going to happen is I'm going to initiate that ping, and the traffic is going to come this way, and it's going to get to router 2. And router 2 is going to look at the packet and say the source IP is laptop 2, the destination IP is 10.0.0.2, which is server 1. And the ping is going to fail because router 2, as we're going to see here in a second, does not have a route to get to router 1. Or to get to the segment, I should say, get to the segment behind router 1. So let's take a look at the routing table right now on router 2, and I suspect that what router 2 is going to have is a default route. So if I were to say EN to go to privilege exec mode, show IP route, you can see that not only do I not have a route to the 10.0.0.0/8, all I have is a static route that's going to send that traffic out the serial 00 interface, which is this interface right here. And it's going to go out now to the, the quote-unquote public internet, because we haven't set our GRE tunnels up yet, and we haven't set up our IPSec. So when that packet reaches router 2, he sends it out that interface to the internet, and the packet's going to get dropped because that's an RFC 1918 address. That's a private inside address that cannot be routed over the public internet. And so that's why we're going to go ahead and we're going to construct these GRE over IPSec tunnels. So let's go ahead and let's see, they want us to ping from PC3 to L2, and this should also fail. And let's run this ping real quick. So ping 172.16.0.2. So can I ping from PC3 over to laptop 2? And we should see that this fails. All right, so there we go. We'll let it go one more. Okay, good enough. All right, so now on to enabling the security features. And again, we had to do this the other day with the routers we were working on, because when you say show version, you can see here that we don't have the security license enabled. So we need to go to global config mode and type in license boot module C2900 technology package security, right? And this is very critical that if you order a Cisco ISR G2 and you're going to need to do IPSec and create site-to-site VPNs, for example, like we're doing here, you must have the security license in order to do IPSec. Without the security license, you cannot do IPSec. So I'll hit enter. Again, we're reminded that this is a 60-day evaluation, and I'm going to say yes, I accept the terms, and the terms are I can use it for 60 days, but sometime before that 60 days ends, I need to procure a legitimate license to make things right, to make sure that I'm properly licensed on the router. All right, so I'll go ahead and say end, write mem, and then reload. So I'll come down here to router 2. We're going to do the same thing. So we'll go to global config mode. I'm going to say license, CENSE, license boot module C2900 technology package security K9. All right, I accept the terms of the temporary agreement. End, whoops, save my config, and reload. And the same thing on router 3. So we'll go from user exec to privilege exec. We'll go to global config, and we're going to say license boot module C2900 technology package security. All right. So again, we accept the agreement, go back to privilege exec, and type in write mem, save our config, and then we're going to reload. And this is definitely one of the upsides of Packet Tracer, is that the reload takes all of about 15 seconds and then it's back up. All right, so we've added in the license. Let's confirm. How do we confirm that? We go to privilege exec, and I'll say show version. And now when we come down here to the bottom, take a look. The security license is now installed. What type is it? Is it permanent? It is not. It's an eval license, right? So this is an evaluation version of the license. Okay, so now we're going to get into the best part of the activity, right? We're going to configure our IPSec site-to-site VPNs first, and then we are going to overlay our GRE tunnel on top of this IPSec configuration so that we get the benefits of GRE in our point-to-point tunnels, and not only do we get the benefits of the GRE tunnels, but they're going to be secured now. Because remember before, GRE is not, again, it is not a secure construct. So there is no confidentiality that's being provided with encryption. There's no integrity that's being provided with the hashing algorithms. There's no authentication being done with any pre-shared keys. Remember when we configured GRE, we didn't do any of those things. And there is no security of securing the keying information, right? That keying material with the Diffie-Hellman groups, with the different Diffie-Hellman groups. So let's go ahead now. Let's take a look here. So it says, first thing we want to do, it's kind of like a 5-step process. So the first step is we need to configure an ACL that identifies the interesting traffic. And the interesting traffic is the traffic that we want to make sure we encrypt, right? So we need to identify that. So that's kind of step 1. Step 2 is we're going to go ahead and create our IKE Phase 1 settings. And those are the settings that we, again, remember, Phase 1 is really the establishment. What Phase 1 takes care of is it sets up a secure channel over which you can exchange the security parameters for the IPSec encryption, the peers, the transform set. So this is going to set up a secure way to do that. And that's kind of step 2. Step 3, we identify our transform set, right? Are we going to use, and again, in the IPSec transform set, you've got 2 protocols. The encapsulating security protocol, right? And the authentication header protocol. And so those 2 protocols work together, right? Or I should say they can work together, but typically they work independently, and they each kind of have their strengths and weaknesses. remember, authentication header, which we'll see here shortly, the authentication header can only provide authentication. That's it, right? It doesn't provide any confidentiality. There's no encryption if you use AH. So that's why you'll see the majority of the use cases that I've seen in the industry is you're definitely using encapsulating security payload, because you want to take advantage of those encryption algorithms to provide that confidentiality for your data. All right, well, let's jump in here on router 1. So we'll say conf T to get into global config, and we're going to go ahead and they give us the access list up there, right? They get us started here, kind of give us a little boost. So we're going to say access list 101 permit IP, and now the source, right? So from what source do I want to be able to have that data encrypted? And well, obviously we want to make sure that we've got the source behind router 1. So that's 10.0.0.0, and then this is going to be a slash, whoops, sorry, get the wildcard mask in there. It's going to be a /8. So instead of the net mask of 255.0.0.0, the inverse of that is our wildcard mask right here. So that is 0.255.255.255. And so from that network to 172.16.0.0, and the net mask here is a kind of an odd one, right? So 0.0.3.255. Well, why is it .3.255? Well, real quickly here, if I were to say it's a /22, right? And you can see looking right here that these are /22s behind router 2 and 3 respectively. So a /22 is 255.255.252.0, right? Remember, if it was a /23, it would be 254, and a /24 is 255. So this is the net mask, and the inverse of this is 0.0.3.255. So that's how we ended up with, and let me see how far back I'm going to be able to go here. Not far enough. All right, I'm going to have to leave this here for a little bit. All right, let me see. Is there a... No, I've never looked to see... Oh, wait. There we go. I've actually never used the eraser. I usually just clear the screen, and actually I see why now I usually don't use the eraser, is because it's going to leave some marks there. All right, well, we'll make do with that, definitely. That'll work. All right, are we back here? Okay, so we're good. All right, so let me go ahead and go back to the command line here. So we're in global config mode. We've just created the access list to identify the interesting traffic. Now, this ACL, as it says up here, is going to trigger the IPSec site-to-site VPN to be implemented whenever there's traffic between R1 and R2 and R1 and R3. You'll notice that it's not between R3 and R2. So it says all other traffic sourced from the LANs will not be encrypted. And remember, there's an implicit deny at the end of the ACL. Now, step B, or I should say sub-step B here, says repeat step 1A to configure ACL 101 to identify the traffic on the LAN of R3 is interesting. So if we come back into our window here and we just basically recall the command that we just had, we would simply say 172.16.4.0, and it's a /22, so the wildcard mask is 0.0.3.255. And so this takes care of identifying traffic that's sourced from the 10.0.0.0/8 network going to either the network behind router 2, 172.16.0.0, or the network behind router 3, 172.16.4.0. Okay, So we've got our ACLs defined here on router 1. Now, let's go ahead and define our crypto ISACAMP policy. So crypto ISACAMP policy, we're going to say 101. And here are the IKE Phase 1, the Internet Key Exchange Phase 1 parameters, right? And remember, Phase 1 is the establishment of a secure channel that's created over which we're going to exchange the larger security parameters of the setup. So this is going to protect the passing of the information that's going to go back and forth for IKE Phase 2. So here we are in IKE Phase, or we're setting up the IKE Phase 1 setting. So we're going to say encryption AES as they request. Our authentication, right? So you could do a pre-shared key or you could do digital certificates. Again, at this level, it's definitely going to be a pre-shared key. Now our Diffie-Hellman group. So remember from the other night, we took a look at some of the Diffie-Hellman groups that exist, and I'm going to pull them up right here really quick, and we'll just say conft and then crypto ISACAMP policy, policy 101. And if I were to say group and do a question mark, and we'll bring this up a little bit here so you can see, take a look at the very long list of Diffie-Hellman keying groups that we can use. Now remember, 1, 2, and 5, as of 2012, you should not be using those groups, right? So Diffie-Hellman keying groups 1, 2, and 5 should not be used, and that you shouldn't have been using them since 2012. Now, 14, 15, and 16, these here, these have been, and again, this is by Cisco best practices, these have been deemed usable through the year 2030, right? So these have been deemed usable through the year 2030. Now, 19, 20, 21, and 24, these are considered the longevity use cases, right? And these are the ones that you should be using for your deployments, not only today, but going forward, right? And the reason for this is that these 19, 20, and 24, these support elliptical curve cryptography, right? Which not only reduces the time for the key generation, but are considered the most secure that are out there, right? So these are the ones that are going to be the longevity of use keys that you should be looking to use. So we're going to pick key 5 here, right? Again, at the CCNA level, they try not to put too much of the CCNA security material in there. So now we've got the IKE Phase 1 parameters set. Let's exit out, and let me go ahead and configure my pre-shared key. So crypto ISACAMP key, Cisco, my pre-shared key, and what is the address of the peer that I'm going to be using this password, this pre-shared key with. And so it's going to be 64.100.13.2 and 102.46.2. All right. So router 1 has its IKE Phase 1 parameter set. Now we're going to move on to the transform set, right? So this is for Phase 2. So we're going to say crypto IPSec transform set. We're going to call it R1_set. You'll notice here it says create the transform set VPN-set. However, it then specifically tells us, and I can't remember where, but it wants us to use, it's here, but then I think it's lower down here that it may mention it wants you to use R2_set and R3_set. And I need to pause for just 1 second. I will be right back. All right, so we've got the R1_set for our transform set name, and now we've got our options here, right? So again, this is kind of going back to the conversation about the differences between authentication header in our transform set as the protocol for IPSec, or using the encapsulating security payload. So as you can see here, and in fact, let me see if I can stretch this out just a little bit more. There we go. as you can see here, we've got two choices for authentication header. We can do MD5 or SHA, right? And with the encapsulating security payload, you have your encryption ciphers, right, for your confidentiality, and you can do your authentication, right, for the integrity, making sure that the packets haven't been manipulated in transit with MD5 and SHA as well. So this is one of the major differences, is authentication header can only provide authentication. It cannot provide confidentiality using an encryption cipher, where ESP can provide both of those things. One of the other drawbacks is that authentication header does not work with NAT, because again, when you're doing NAT, you're changing the source and destination IPs, and authentication header, that's exactly what it's checking for, right? So that's another drawback. So again, the most significant difference though is that the encapsulating security payload, if you choose this as your IPSec protocol, you can satisfy both confidentiality and authentication or integrity by using ESP. And real quickly, if I were to come over here, and we'll just exit out of here, and if I were to type in crypto IPSec transform set, and we'll just say, what name do we use? R1_set over here. And if I were to type question mark, you can see that on the real Cisco iOS, you have many more choices, right? And it's typically a good rule of thumb to go, and again, all things being equal, right, that the larger the number with the, whether it's the authentication header protocol or with the encapsulating security payload protocol, the larger the number, typically the more secure, right? And again, I caveat that by saying all things being equal, because again, if you've got a really bad or easily exploitable cipher, it doesn't matter how many bits are in your key, right? It's going to get cracked pretty easy. So as you can see, again, lots of choices to choose from for the cipher, for the encryption piece, and then ESP also provides quite a few for the authentication and integrity. And again, you can also even throw in compression if you wanted to use compression, right, using the LZS. So this is just a look, again, to take a look at the real Cisco iOS, keeping in mind that the major difference here between ESP and AH is that AH only provides authentication. It does not provide any form of confidentiality / encryption, right? So R1 set, so we're just going to use ESP AES and then ESP SHA-HMAC, right? So we're going to have the encapsulating security payload providing the confidentiality with AES and the integrity and the authentication, right? And here in phase 2, IKE phase 2, when we say the authentication piece, we're talking about the integrity to make sure that the packets are not tampered with while they are in transit. Okay, so we've got that down. So now we're going to come back and we're going to do our crypto map. And this is where we're going to kind of pull everything together from our phase 1 and phase 2 settings, and we're going to say we're going to take those phase 1 and phase 2 settings, and now we're going to put together a map, and we're going to apply this map to an interface. And the map basically identifies the peers with whom we're going to be creating our site-to-site IPSec VPN, and it's also going to identify our transform set, and the ACL gets associated. So R1_map 101 IPSec ISACamp. So who are our peers? So set peer, and the first peer is going to be 64.100.13.2, and that's router 2. And then we're going to come back, I might as well wipe this all out here, 102.46.2, that's router 3. And what transform set do I want to use in my map here? We're going to use R1_set. And what's the ACL that we need to match? Match address, 101, exit. So we've got all of our crypto configured here. Now let's jump on to interface serial 000, and apply this crypto map, R1 underscore map. And as you can see, it's telling us that the ISACamp is on. So now, if I were to go to server 1 now, remember, from server 1 I could ping successfully. Let me see. Let's try to ping. Actually, we were pinging the other way. So let me pull up laptop 2. And what happened? The request timed out there. Which way were we able to go? Let me see. Well, it's not going to work that way now. I'm trying to remember when we pinged earlier. Well, actually, it was because we didn't have the tunnel set up, so that's not going to work now either. So I was going to test connectivity, but we're going to let that go right now. And actually, if I were to try to ping, let's see if you can ping from router 3 up to router 1's 209.165. This is the serial 000 interface on router, and I can't read that. I wrote on top of it. So it's .2. All right, so we're going to go ahead and say .2. All right, so we still have connectivity between router 3 and router 1. And what about between router 2 and router 1? Although what I'd like to do is try to ping the address behind it. However, we're missing the routes right now. So can I still ping 209.165.118.2? And I can. All right, so now we're going to configure the crypto map. We're going to configure the IPSec parameters on router 2 and router 3. So we're simply going to repeat those steps that we just did for router 1 on router 2 and router 3. Now we need to modify the set, and so the set name would just be R2 underscore set, R3 underscore set, and we're going to use the same extended ACL number. And note that each router only needs one encrypted connection to router 1. There is no encrypted connection between R2 and R3. And that's what we were identifying here, is that there is no GRE over IPSec tunnel that will be running between router 2 and router 3. So you can think of 2 and 3 as the spokes, and 1 is the hub. And I'm a little surprised that I'm running out of space again. So give me a second here. I got to clear up some disk space. I'll be right back. All right, so we're going to configure the same IPSec site-to-site VPNs between router 1 and router 2, and between router 2 and router 1 and router 3 and router 1. So now we need to get onto router 2 and make the configuration changes for router 2. So let me scroll back up here just a second. All right. So again, we want to go ahead and configure our ACL. So we'll go into global config mode, and I'm going to say access list 101 permit IP. Now remember, what's the source here for router 2? My source is going to be 172.16.0.0, and the wildcard mask is going to be 0.0.3.255. Remember, this is a /22. So traffic sourced from that subnet range going to, what's our destination here? It's going to be 10.0.0.0, and our net mask value is going to be 0.255.255.255, because this is a /8. So that's going to be the ACL that we configure on router 2 to match our interesting traffic. So let's do our IKE phase 1 setup here. So crypto ISACamp policy 101, and we're going to say encryption AES. We're going to use the authentication of pre-shared keys. We're going to use the Diffie-Hellman group 5, and that's it. Now we're going to create our key between router 2 and router 1. So crypto ISACamp key, here's our pre-shared key of Cisco. And who is my peer? If I'm router 2, my peer is router 1. So router 1's publicly routable IP is 209.165.118.2. All right, so now we move into the crypto IPSec transform set configuration for R2 underscore set. We're going to use ESP AES, and we're going to use ESP, and these need to match, by the way. It's very important that these match between the IPSec peers, right? If these don't match, then phase 2 is going to get hung up. So we say return. Now we're going to create the crypto map R2 underscore map, and 101 in IPSec ISACamp. So who's my peer? My peer is going to be 209.165.118.2. And let me get the peer keyword in here. And let's set my transform set now, which is R2 underscore set. And what is the ACL I'm going to match? It's 101. So let me exit out. Let me go into interface serial 000, where I'm simply going to apply my crypto map R2 underscore map. And you can see that it says ISACamp is on. So now we have a successful tunnel between an IPSec site-to-site VPN right now between R1 and R2. So if I were to try to ping, is it going to work right now? Ping from laptop 2 to server 1. Well, let's try it. And think about it. Would this work? It's unicast traffic, right? So is it going to work? And again, it looks like the requests are timing out. So it's very possible that we don't have a route. Oh wait, did we get that last? Finally got that last one? Good, okay, good, it caught up in there. So we got the last one in there. So now we have connectivity between laptop 2 and server 1, because again, this is unicast traffic, right? It's unicast traffic, so that's going to function. And this is encrypted traffic from the moment it leaves router 2 until it gets here to router 1. So this is a site-to-site VPN between router 2 and router 1. So, and it's functional. Now let's pull up router 3 and configure our site-to-site VPN between router 3 and router 1. So we go to global config. We're going to create our access list. So access list 101 permit IP. Now what is my source? 172.16. And this is the source network from which the traffic is being generated. 0.0.3.255, right? It's kind of that tricky little /22 net mask value. And again, this is between router 3 and router 1, right? So where's my destination network? 10.0.0.0, and my net mask is 0.255.255.255. So there is my ACL defining the interesting traffic. Let's create our crypto ISACamp policy for the phase 1 keying. For IKE phase 1 encryption AES, Diffie-Hellman group 5, and authentication pre-share key, right? So we'll go ahead and exit out here. Let's create our key. Crypto ISACamp key is going to be Cisco. And who is my peer that I'm going to be working with here? It's going to be router 1, 209.165.118.2, right? All right, so there are my phase 1 settings. Let's get our transform set done for IKE phase 2. So crypto IPSec transform set R3 underscore set. We're going to use ESP AES and ESP SHA HMAC for the integrity and the authentication. Now we're going to create our map. So crypto map R1 underscore map 101. There we go. And IPSec ISACamp. And if I pull back here, you can see that really that's our only choice, right? So we're using IPSec with ISACamp. All right, so let's set the peer in here. So set peer address, set peer to 209.165.118.2. And then we're going to set the transform set that we're going to use in this map. So set transform set is going to be R3 underscore set. And we're going to match the ACL 101. And then we're going to exit out, go into interface serial 000 and say crypto map R3 underscore, whoops, map. And did I type in something else up here? Ah, yes, I typed in R1 underscore map. So do show run. And we're going to have to say no. And we get to do the bonus lab here. So copy, paste. Forgot I was on router 3. So crypto map R3 underscore map 101 IPSec ICE. That should be grabbing it. I'm under interface config mode. I apologize. So let me back up one step here. So crypto map R3 underscore map 101 IPSec ISACamp. So we're going to set the peer to 209.165.118.2. We're going to set the transform set to R3 underscore set. We're going to match the address for our ACL is 101. Now we're going to exit out, and I'm going to drop into interface serial 00, and we're going to apply the crypto map R3 underscore map, which now exists. All right, so ISACamp is on. So I'm going to come over here to router PC3, and let's check connectivity here. Can I ping 10.0.0.2? Well, let's keep in mind that the site-to-site IPsec VPN is configured, right? So just like when I went from laptop 2 up to, and there it is, to server 1, it took a couple pings to get through, for a couple delays to get through, and then it finally made it through, and so we are now good to go. So if I were to pull up router 1 here and say show IPs or show crypto IPsec SA, we should have a pretty robust set of data here, because router 1 is involved in 2 IPsec security associations. So take a look here. You can see that we've got the inbound encapsulating security payload security associations listed, right? We'll keep going down. There's the outbound. And we get some good information here. It shows us the map, the name of the map that we're using. Shows us that we're using ESP AES in our transform set, along with the ESP SHA HMAC for integrity. Shows us the local crypto point. Local crypto endpoint. And this is important. We're going to take a look at this when we overlay GRE onto the IPsec. Let's see if the MTU is going to change on the interface. Right? So it gives us all of the information. Here's our other security association that we've got. All right, so let's work through that. Okay, good. So we've got both of those set up. So now what we're going to need to do, and I need to bring this down a little bit here, right about there. So all of our crypto is done, right? We've created the IPsec crypto required to now lay the GRE point-to-point tunnels over our IPsec. So let's go ahead and take a look at that. So on router 1, we're going to go ahead and create our tunnel. We'll do the first one to router 2. So we need that virtual tunnel interface, right? Remember, it's just like a loopback address. It's in software and it's virtual. This does not physically exist on the router. So I just say interface tunnel 0. I'm going to put my IP address now on my tunnel interface. And so if I reference the diagram up here, you can see it's 192.168.0.1, and it's going to be in the exact same subnet as the other side of the GRE tunnel over on router 2, and it's a /30. So we're 192.168.0.1, and my net mask is 255.255.255.252, which is my /30. So I create the tunnel interface, I put my IP on here, now I just need to say tunnel source, and that's going to be my serial 000 interface, which has that publicly routable IP on it. And then what's my destination out on the internet? Well, my tunnel destination is going to be the publicly routable IP on router 2, 64.100.13.2. Now the last thing for me to do is to kind of identify what kind of a tunnel is this. Well, tunnel mode GRE IP, because I'm doing IPv4. Remember that you have some other choices there. In the real Cisco iOS, you can pull up, we'll say interface tunnel 0. I'm sorry, global config, interface tunnel 0. And if I were to say tunnel mode, GRE question mark, and we'll scoot that up a little bit, you can see we've got three choices here. IPv4, IPv6, or multi-point GRE over IPv4, right? So you do have some additional choices there with the real Cisco IOS. So if I was doing an IPv6 GRE point-to-point tunnel, I would identify the mode as GRE IPv6. Okay, so let's pull this back here. So that's our tunnel on router 1. So now let's go ahead and repeat the steps that we just ran here. And let me make sure I'm reading this correctly. It has to be done on R2. There's no question about that. Okay, configure, repeat steps 1A through F to create the tunnel 1 interface on R3. Change the addressing where appropriate. I'm looking for what they are going to ask for here. Repeat steps 1A through E with R2 and A through E with R3. It's interesting. They ask you to do the same thing here with R3, but then they turn around and they want you to do it again, and they mention R3 again. And R3 is only going to have a single GRE tunnel over the IPSec, and that's the one that's indicated here. All right, so we're going to go ahead and drive on. We know we need the tunnel on R2, so let's go ahead and take care of that. So I'm going to type it in and write memory. So we're going to save our config. And once we've saved our config, let's get router 2 up here. And let's knock out our GRE tunnel over our IPSec config here. So I'm going to say conf t to go to global config, and then interface tunnel 0. So what's the first thing I do? Just like my loopback address, I'm going to throw my IP on here. So IP address, and this is going to be the other side of the tunnel from router 1. So this is 192, and this is usually an RFC 1918 address, .0.2, and this is a /30. And then what am I going to put on here? Well, what's the source for me? My tunnel source is also serial 000, because that's where my publicly routable public-facing IP is at. And then my destination, where am I going across the internet? I'm going to 209.165.118.2. And so that's my destination. Then what kind of a tunnel is this? Tunnel mode GRE IPv4, right? So this is an IPv4 tunnel. All right, so that takes care of router 2. So now, what do you think? When I type in ping 10.0.0.2, so we still have connectivity. What if I trace route to 10.0.0.2? So my first hop shows as my default gateway, the 172.16.0.1, right? And that is the default gateway. And then I don't see what happens for the hop after that, and then I end up at the endpoint, which is server 1, right? And I apologize here. This is, I'm actually cleaning up some data here, so this should be... All right, well, I'm going to pause here very shortly, and then we'll be right back. All right, so if we try to ping, we can actually successfully ping over there. When we trace route, you'll notice that we don't see that next hop that we take. We end up right at the server. Okay, so we've configured router 2, and the tunnel interface is up. And let's go ahead now and configure actually, I'm sorry. We've got our tunnel configured there, so we're good to go there. Let's go ahead now and configure on router 3 our GRE tunnel here. Should already be active. And let's go ahead and repeat the steps here. So I'm going to say interface tunnel 0. And the first thing we do is we add our IP address. So the IP address is that RFC 1918 address. So we're a 192.168.0.6, right? And this is /30. And then we're going to put our tunnel source, right? So the tunnel source is, again, that outside internet-facing interface, serial 000. I could put the IP, but it's just as easy to put the interface. And then what's my tunnel destination? Well, it's going to be router 1. And its global, or I should say its outside-facing globally routable IP 209.165.118.2. And what kind of a tunnel do I have? Tunnel mode, it's a generic routing encapsulation tunnel that's going to be using IPv4. All right. So we've now got the tunnel set up between router 3 and router 1 and router 2 and router 1. So we need to configure a route right now, because even though the traffic, the unicast traffic, right? Remember, this is unicast traffic when I'm pinging. Unicast traffic can go across those IPSec site-to-site VPNs, right, without any problem. When we did the trace route here, did it take the tunnel interface? It did not, because what is R2? If I say show IP route or do show IP route, what is R2 going to do in order to get to 10.0.0.0? R2 is going to send that traffic out its directly connected serial 000 interface, because that's the default route, right? So it's going to go out via the IPSec site-to-site tunnel over to router 1, and it will successfully make it to server 1. However, is that what we want here? We actually want it because we may be doing broadcast traffic or multicast traffic. We want it to go across the IPSec, the GRE tunnel that's over our IPSec right now. So in order to make that happen, we're going to have to add some routes. So the first thing we need to do is we're going to define a define a route from router 1 to both of the /22 networks behind R2 and R3 respectively, and we're going to use the tunnel interface as the next hop IP. So instead of letting this traffic get pushed out the default route, which is going to be out the serial 000 interface, we're going to tell it, I want you to use the GRE tunnel. So on router 1, we'll go to global config, and I'm going to say IP route 172.16.0.0, and let me make sure I've got that right. So yeah, my route to get to 172.16.0.0, and this is 255.255.252.0, is going to be the next hop IP in the tunnel. So from router 1's perspective, my next hop IP is going to be the IP address of the tunnel interface on router 2. Right, and that's going to get me to the network behind router 2. Now the next route that I need is going to be over to the other /22, 172.16.4.0, which is over behind the LAN segment behind router 3, and that's the tunnel interface behind on router 3 is 192.168.0.6. So now router 1's traffic will use the tunnel interface. So if I'm on server 1 right now, if I ping 172.16.0.2, you can see that we've got connectivity. What if I do a trace route over to 172.16.0.2? So let's see where it goes. So the first hop, as you would suspect, it's going to go to its default gateway. However, as you can see, we don't get any responses back because the traffic is encrypted. And then it makes its way over to 172.16.0.2, right? So again, though, it's not clear as to whether or not we're hitting the tunnel, okay? Because again, we see these asterisks here, and we don't get the next hop IP printed out for us. All right, so define a route from R2 and R3 to the 10 network. So let's go ahead and do that. Let's say that we are going to IP route. So my route to the 10.0.0.0/8 which is 255.0.0.0. So my route to get to that 10 network is going to be the tunnel interface of router 1, 192.168.0.1, and I'm going to make that same statement here on router 3. So my route to get to the 10.0.0.0 network, whoops, on router 1 is going to be 192.168.0.5, which again is the next hop IP of the tunnel interface on router 1. All right. So we've got all of our interfaces entered in there. Let's see, we've got that set up. And it looks like we've got 3 additional points. Let me do a quick check here. And let's see the tunnel 1 on route. Oh, I apologize. So there is a tunnel 1 that needed to be set up. I moved right on after I did tunnel 0. So let's actually wrap up here. We got to do one more tunnel. So interface tunnel 1, and this is going to be the tunnel between router 1 and router 3. So IP address of the tunnel is going to be 192.168.0.5. It's a /30. So then my tunnel source is going to be serial 000, and my tunnel destination is going to be the next hop globally routable IP, not the tunnel interface IP, but 64.102. I'm telling it, where does the tunnel terminate? .2, and then what kind of a tunnel do we have? So we'll say tunnel mode GRE IP, and there we go. All right. So we've got everything configured here. Let's do our last attempt here to ping and confirm connectivity. So attempt to ping the IP address of server 1 from laptop 2. Oh, there we go. So as you can see, there's a significant difference here, right? When I traced before, what happened? Well, it was encrypted. It hit the IPSec site-to-site VPN. Now that I'm telling it to go over the tunnel, we know that it's going over the GRE tunnel, which is protected by the IPSec, right? So we've overlaid the GRE tunnel onto the IPSec site-to-site VPN. And now we see that my first hop is my default gateway. My second hop is the tunnel interface on router 1. Then I hit the server. So I can clearly see, and if I can trace there, I should certainly be able to ping. And so that works great, and it shows that I'm going across the tunnel. How about PC3 from here? What do you think? Ping 172.16.4.2, and we're not going to have any luck at all. Because again, there's no tunnel between the two networks. We did not do an GRE over IPsec tunnel between those two networks. All right, so we'll do a Control-C here. And now let's go ahead and jump onto PC3, and I'm going to say trace route over to 10.0.0.2. Does this go through the tunnel? It certainly does. And there's your proof right there that my second hop after my default gateway is over to the tunnel, the GRE tunnel IP of router 1. And if I can trace there, I can certainly ping there. So we've got connectivity. All right. So again, this wraps up a very real-world scenario where you would be doing GRE over IPsec. I think the only thing that I would like to have seen added here would have been configuring either OSPF or EIGRP between these to show that with the GRE tunnel, we can still have the GRE on top of the IPsec, and we're going to be able to support broadcast and multicast traffic that's required for those adjacencies to be established and maintained. All right. Again, this is Packet Tracer Activity 7.3.2.8. I appreciate you watching, and I will see you guys on Saturday.